Okay, hey, let's take a look at Unit 3, Worksheet number 2. I'm going to attempt to do this one with you guys here. Haley is currently stopped in her car at a stop sign. She speeds up from rest to 30 meters per second in 5 seconds. So the formula we're going to be using all day is going to be that final velocity equals acceleration times time plus whatever that initial velocity is. All right, now this one we know her final velocity is 30 equals an unknown acceleration times 5 plus 0 because she starts from a resting point. We can solve that 5a equals 30. 30 divided by 5, let's see, that's going to equal 6 meters per second squared for the first one. Okay, so it should be pretty easy, kind of just plug and chug on number 1. Number 2, Joe is running at 6 meters per second. Suddenly someone runs in front of him. He's forced to stop. Takes him 0.2 seconds to come to a stop. What is his acceleration? Same formula as before. Final velocity equals acceleration times time plus initial velocity. This time we know his final velocity. He's going to equal 0 at the end. We don't know his acceleration, but we know the time is 0.2, and he was running at 6 meters per second. All right, so we do some math magic here. We get negative 6 equals 0.2a. Means you got to time both sides by 5 to get out of there. So a is going to be negative 30 meters per second squared. Now, we haven't talked about it yet, but gravity. Gravity equals 9.8 meters per second squared. So he's stopping with an acceleration that's 3 times that of gravity. That's going to be a bad day. That's going to be a painful stop that he's got there. All right. So next one. Jet's taxiing down the runway. Receives word must return back to pick up Emma, who's late for the flight. If the jet was traveling at 45 meters per second, initial velocity, and it takes 5 seconds, that's time. Halt, that's going to be final velocity. All right. Set up the same way. Final velocity of 0 equals 5 times the acceleration plus 45. Slide that 45 over here. And you get a is going to equal 9 meters per second for that one there. All right. Number 4, while driving a sports car down at 20 meters per second down the road, Dylan becomes a slow-moving dump truck, decides to pass it. He's accelerating at that. Okay, so with this one, we have a final and initial velocity that are not 0. So that's a nice little challenge for us here. So we're going to have an initial velocity of 20. We're going to have a final velocity of 43, and here's our acceleration. So we're looking for time here. So 43 equals 5 times t plus 20. All right, slide this 20 over. So we're going to have 23 equals 5t. Divide that. Let's see, we got t equals 4.6 then. I think that's 4.6. Try and do that in my head. 4.6 seconds. Okay, sliding on down the page. Parker is sprinting to lunch. He takes off from a standstill with an acceleration of 2.5 meters per second squared. He accelerates for 6 seconds down the hallway. How fast will his final velocity be? So we're trying to solve for that final velocity. We know that his acceleration is 2.5. Let's write that correctly. We know he's going to be traveling like that for 6 seconds. And he starts off from a standstill. So that final velocity is going to be, let's see, what is that, 15 meters per second? That should be right. That is cooking. That's like 8 second 100 meter dash pace there. That's moving. All right, a little faster than Parker can run. A cheetah can accelerate at the top speed of 31 meters per second in 4 seconds. What's the acceleration? So we're accelerating. We're going to assume that starting from 0, there's our final velocity, and there's our time again. So we're going to get to 31, 4 times whatever that acceleration is. It's going to be plus 0. So we're going to take 31 divided by 4. So A is going to equal, should be what, 7.75 meters per second squared. Once again, I'm just trying to do this in my head here. My calculator is recording right now, so but that would be how you set up the problem there. 2 left for us. Ethan is zooming down the hallway at 14. I'm sorry, down Highway 14 at 40 meters per second. Sees a police officer and brakes to a speed of 23. It took him about 2.1 seconds to lower his speed. What was that acceleration during that time? Okay, so once again, we have a final and initial velocity that are not 0. So he ends up going 23. Initially, he was going 40. And here's our time. So we got to solve for A. Remember that formula again. All right, v sub 0 means v at time equals 0. Final velocity is 23 equals, we're searching for A, 2.1 A plus 40, subtract 40 from both sides. Oh boy, give me 1 second, I got to do a calculator for this one. That one is beyond my mental capacity right now. All right, so you get an acceleration of negative 8.1 meters per second squared. Once again, that he's feeling that. That's almost as much as gravity there, so that's a lot. Remember, you don't feel velocity, you feel acceleration. Wyatt is sprinting and sees someone about to pass him. He accelerates at 1.2 meters per second squared over the course of 0.5 seconds to achieve a final velocity of 8.9. Oh boy. Acceleration, time, and final velocity. We're looking for his initial velocity. So 8.9 equals 1.2 times 0.5 plus v sub 0. I gotta do some calculator work again. 1.2 times 0.5. I should really be able to tell you that's 0.6 without looking it up like that. 0.6 plus VO equals 8.9. Subtract 0.86 from each side. You get 8.3 equals his initial velocity. All right. So there is worksheet number 2, the 8 questions there. Make sure you check your work and how you did on those 8.